this video is going to be about limiting reagent. Instead of talking about what a limiting reagent is and how to do all of that, we are going to be taking an example. So 2H2 plus O2 gives rise to 2H2O. Now, based on the stoichiometric calculations we've done till now, so the number of moles of hydrogen are 2, number of moles of oxygen is 1. They give rise to 2 moles of water. Now, let's assume you have a reaction mixture, and in this mixture, it has 2 moles of hydrogen and 2 moles of oxygen. Now, based on the above information, we know that 2 moles of hydrogen is required and only 1 mole of oxygen is used or is required, which means in our reaction mixture, when this two will react to give us water, you will have 1 mole of oxygen remaining along with the product of 2 moles of water. Okay. So this means that the hydrogen over here is the limiting reagent because it is being used up completely in the chemical reaction, whereas the oxygen is the excess reactant. So hydrogen is the limiting reagent and oxygen is the excess reactant. So basically what you can see is that when the hydrogen gets used up completely in the chemical reaction, the reaction is stopped, which makes it the limiting reagent. So basically the reactant that gets completely consumed in a chemical reaction is called the limiting reagent. So there are cases when the reactants are not present in the required amounts. So here, like in this one, so like in the balanced, similar to how much it has to be in the balanced chemical equation, it's not to that amount. So you have certain amount of reactants which are remaining along with the product. So here in our product, you have 1 mole of oxygen still remaining along with 2 moles of water. So that's about it. So limiting reagent is completely used up in a chemical reaction, whereas the excess reactant is present after the chemical reaction. Okay, let's do problem for limiting reagent. 50 kilograms of nitrogen and 10 kilograms of hydrogen are mixed to produce ammonia. Now we need to calculate the ammonia formed and we also need to calculate we need to identify the limiting reagent. So we need to calculate the mass of ammonia formed. So let's first think about the balance, or rather write down the balanced chemical equation. So N2 plus 3H2 gives rise to 2NH3. All in gaseous state. Okay, so the moles of nitrogen, so 1 mole of nitrogen and 3 moles of hydrogen react to form 2 moles of ammonia. So the number of moles of nitrogen would be equal to mass in grams divided by the molar mass. Okay, so molar mass is in grams per mole and we will basically convert it to give us. So the molar mass of nitrogen N2 is 28. So 50.0 kilograms into, since it's in kilograms, we have to convert it to grams, and we do that by multiplying it with 10 to the power 3 and dividing this by the molar mass, which is 28 grams per mole. And when you cancel, grams will get cancelled, mole will go to the numerator and give us the value in moles. When we simplify it, we get 1.786 into 10 to the power 3 moles. So first we are calculating the moles of nitrogen. Next we will be calculating the moles of hydrogen. This is again by mass in grams divided by the molar mass. So here you have 10.0 kilograms, 10.0 into 10 to the power 3 grams divided by the molar mass, which is 2 grams per mole. That is equal to 5.0 into 10 to the power 3 moles. So first we have calculated the number of moles. To understand this part of the calculation better, you should check out the video I've done on calculation using mole concept. Now 1 mole of nitrogen requires 3 moles of hydrogen, right? So if 1 mole of nitrogen requires 3 moles, then 1.786 into 10 to the power 3 moles of nitrogen requires how much? This is done again by cross multiplying. So 3 into 1.786 into 10 to the power 3, which gives us 5.36 into 10 to the power 3 moles. Okay, so all we are doing, we are considering 1 mole of nitrogen requires 3 moles of hydrogen. Then 1.786 moles of nitrogen will require how much of hydrogen? That is, it requires 5.36 into 10 to the power 3. So, but the moles which are present is, number of moles of hydrogen which is present is only 5.0 into 10 to the power 3 moles. So, which means that nitrogen is in excess while hydrogen is the limiting reagent. You only have 5.0 into the power 3 moles, which is higher. So, you can also flip it. You can also say that, okay, 3 moles of hydrogen requires 1 mole of nitrogen. Then 5.0 into 10 to the power 3 moles of hydrogen would require how much of nitrogen? All we are seeing is we are comparing the amount of number, or rather we are comparing the number of moles. Okay, so here you have the number of moles of hydrogen in this case is higher than this one, which means hydrogen is the limiting reagent, which means that nitrogen is the excess reagent. Okay, now we also know that three moles of hydrogen gives rise to 2 moles of ammonia. Okay, so 3 moles of hydrogen gives rise to 2 moles of ammonia. I'm just going to write NH3. So 5.0 into 10 to the power 3 moles of hydrogen will give us how much of ammonia. This is again done by cross multiplication to give us 2 by 3 into 5.0 into 10 to the power 3 moles. This gives us 3.3 into 10 to the power 3 moles of ammonia. So we are just basically taking into account that 3 moles of hydrogen is giving us 2 moles of ammonia. We know the amount of hydrogen which is present, that is 5.0 to 10 to the power 3 moles, that gives us ammonia. Here, however, you cannot take nitrogen. The reason we didn't take nitrogen, I mean, I know, see, you if you think about it, the calculation would have been easier. But the reason we didn't take it is because our hydrogen is the limiting reagent, which means all of hydrogen is being used for the chemical reaction, and the ammonia is the excess one, which means not all of it is going to get used, right? So if all of it is not going to get used, then the amount of ammonia which will be produced will be different. So our limiting reagent is hydrogen. That's why we are considering hydrogen for the calculation of the number of moles of ammonia. Obviously, we can find out the mass of ammonia which is formed. Will be equal to the number of moles into the molecular mass, or molar mass rather, sorry. Given mass, right? So usually number of moles is given by mass by molar mass. We're simply shifting it here. So 3.3 into 10 to the power 3 moles into 17 grams per mole. So mole will get cancelled, leaving this grams. So 56.1 into 10 to the power 3 grams, or that's also equal to 56.1 kilogram. So in this problem we just took first we had started with identifying the chemical the or rather I'm sorry the limiting reagent. I'm so sorry. We started with the limiting reagent. That was done basically by first calculating the number of moles of nitrogen and the number of moles of hydrogen based on the formula mass in grams divided by the molar mass, and that gave us these two values. And now we thought, okay, 1 mole of nitrogen gives rise to 3 moles of hydrogen, and 1.786 into 10 to the power 3 moles of nitrogen will require how much? So it requires 5.36, which is more than what is present over here, which makes hydrogen the limiting reagent. The moment the hydrogen gets consumed, the reaction will get stopped. So that's why over here we considered 3 moles of hydrogen and not 1 mole of nitrogen, because hydrogen is the limiting reagent. If you had considered nitrogen, then the calculation would be wrong, because according to this it requires more amount of hydrogen, which is not there. So there is unreacted nitrogen still left. So here the hydrogen which is completely getting consumed is considered, and that gives us the amount, the number of moles of ammonia which is being formed, and then the mass of ammonia which is formed is equals to the mole into the molar mass. This is again this formula only which we generally use. So with this we finish limiting reagent, and the next video will be about various calculations, or rather the various ways we show the concentration when a particular reaction is taking place in a solution. That's all for now.